Good afternoon, everyone. My name is Mark Brewer from Schrödinger. First of all, I'd like to thank Nora and ChemAxon for inviting me to be here. For anybody that doesn't know Schrödinger, we're a leading provider of scientific solutions to both the life and material science industries. And today, I'm going to talk about a platform called LiveDesign, our LiveDesign platform in the context of drug discovery. Just a second. So what is LiveDesign? Well, our LiveDesign platform is an agnostic browser-based enterprise platform to enable collaborative design between teams, within drug discovery teams and between drug discovery teams. So we're talking about end users again. In this case, mainly medicinal and computational chemists. It's a modern web-based interface that provides an intuitive user experience for ideation. And what I mean by that is the process by which ideas are generated, explored and investigated, and then managed alongside other project data as it comes in. In this context, it's a very different proposition from something that just sits on a database and looks at it and is then used to analyze or visualize. This is working in the framework of virtual compounds. We're looking to sort of foster a make, and test hypothesis with this software. So to take that thought a little bit further, we're talking really about a platform that enables real-time collaboration. We talked a lot about the importance of collaboration and how it's such a growing trend in the industry. This is aimed at real-time collaboration, which is something, again, a bit different. So taking this example up here, you could take both people, two pairs of individuals in a project could be talking to one another about results, looking at exactly the same interface and adding to it in real time. I've actually worked on projects with this where I've done this with people in different time zones. That's how easy this is once you've made everything available through a browser. It could also be in a team meeting environment, shown down in the bottom corner there, where ideas are coming in thick and fast. If everybody's there with their device, typing in ideas and structures, nothing's getting lost. It's all going into the back-end database, and it's there for future use, and it captures the thought process at the time. There's no longer any need for a scribe as such, someone writing down structures and getting them in SD files. So to take this a little bit further, here's a concrete example of how this technology has developed, had a measurable impact on a real-world drug discovery project. One of the end users will typically start with an idea, they'll draw the structure. In this case, we'd be applying a physics-based potency model. We'd want to inspect the results and then make a decision about whether we take the compound forward or not. Before we introduce LiveDesign into this workflow, it could take days outside of a project meeting by the time the idea has actually been sort of converted into some electronic format and then modeled and then passed back and then maybe viewed with a modeler. This doesn't have to happen with LiveDesign anymore. The results are ready for inspection anytime once the calculation's complete. Before I show some of the features of LiveDesign, I'd like to take a few words just to talk about our integration with ChemAxon. We're very pleased to partner with ChemAxon. We're using Marvin Sketch and JChem-Base already in LiveDesign, and very recently we're using Plexus extensively to help enumerate this virtual compound space using both Marcouche and reaction-based enumeration. A lot of our end users are going to be medicinal chemists. They'll know what chemistry is on the table. They want to be able to know which reactions they can enumerate and to be able to tie them with the appropriate compound and building block libraries, etc. So turning to a few features of the platform, it's obviously very important to be able to compare experimental and predicted values. That's enabled. We also have plotting and sort of data analysis capabilities within the package. It's very easy to calculate property and model properties, both for real compounds that might be in the repository and virtual compounds that, say, for example, have just come through from a Plexus enumeration. It's very easy to run three-dimensional docking calculations in real time and look at the results as shown on the right-hand side. It's very easy to add compounds from a variety of sources, both through the sketcher, through file import, and searching through existing compound chemical databases. The visualization is enabled through PyMol, and you could be looking at three-dimensional models or X-ray crystallography results, for example. We have tracking, which is very important. We've already heard today how important audit trails are, so it's good to log the sort of scientist and invention date. And this is also a sort of very nice feature to help with the collaborative aspects of what we're trying to do here. It's sort of learnings from social media. We can attach comments to any molecule. So any annotation or thought process that has been attributed to a molecule gets captured in free text format. And you can really see what the sort of decision-making process was at the time the idea first came up. And then when you revisit it, if in the light of new experimental data or a more predictive model, it may be advantageous to go back and really see what the thought process is at the time it was first invented. And finally, and I think this is the most important aspect, is this ability to share information interactively, which really makes for much more productive brainstorming sessions and really doesn't allow any good ideas to fall through the cracks, which can sometimes happen. So I'm not going to go through all of these in the interest of time, but thank you for your time today, and I look forward to talking to some of you in the break. Thank you.